So in the past, we learned about electrochemical cells. We have two types of electrochemical cells. Galvanic cells are spontaneous. That's what we have been studying in the past. Now we're going to study electrolytic cells, which are non-spontaneous. So if the electron does not want to go to a certain metal, we have to use electrical energy to force that. Okay, so sometimes you've heard of the term galvanizing, or it's galvanized steel. It's a process of combining steel with zinc so that when it's exposed to oxygen in the air, it'll not turn into rust, or that's called corrosion. So we have some uses of electrolysis. The main goal is to produce an active metal. An active metal means it's a metal that has its electron, so it's going to give it away in the future. So to produce magnesium with a zero charge, you have to force electrons to it. To make sodium with a zero charge, normally sodium appears on Earth as Na+, you have to use electrolysis to force electrons to it. So now it's an active metal, as it now is Na with a zero charge, and it's a solid. Aluminum with a zero charge, it's also an active metal. Okay, there's also something called electroplating. Electroplating is when you use electrolysis to deposit a very thin layer of one of the metals on another metal to improve beauty. Maybe you want it to make it look like gold. And brass is actually, it looks like it's gold, but it's not gold. It's copper and zinc. And also it'll be resistant to corrosion or rusting. Okay, so here you can, this is a picture of nickel plating. So if you want to take a piece of metal, I don't know, maybe your bicycle, and you want to coat nickel on the outside of it, you can do electrolysis. And here's the picture of what's actually happening. So if you want to do a nickel plating on a metal, first you need nickel as a source of your metal, okay? So the nickel will be attached to a battery, and that battery will have a positive charge as it pulls electrons to itself. Now the nickel here will turn into nickel plus 2 as it gives up 2 electrons. Okay, so this is a positive electrode. This is also a positive electrode. So now the electrons are coming here, and the battery, this is negative now because electrons are coming from it, and so this electrode is also negative. Let's say you have a ring, and the ring, maybe a piece of jewelry or an earring, whatever it is, wants to be coated with nickel solid. So the electrons will go through here, and the nickel plus 2 that's in solution will accept the electron and be plated on the outside of this ring. Now your ring is nickel plated, and this is how it works. Okay, now to make this happen, you can measure the amount of electrons going through. You can measure the voltage here, and that will tell you, all of that will tell you how much nickel solid in moles or grams you can use to plate the ring. So this is called quantitative aspects of electrochemistry, and that's what we will be doing next. We are able to quantify how much nickel we can put on this piece of metal, or this piece of metal, whatever it is. Okay, to do that, we need to know some ratios. Okay, so the first one is, so this is the quantitative aspects of electrolysis. That means we're able to measure exactly how much nickel we are going to be making, nickel solid. So we have to learn some ratios. Okay, so a watt is W, is the energy used per second. Okay, so that is how much wattage is. Now there's also something called current, which is A, or amps. Okay, that's the unit for current, is amps. Amps is, if you imagine electrons flowing through this point, it's the amount of charge passing through a certain point per second, or per unit of time. That's the current. Okay, and that current is also written here in your formula sheet. I is a symbol for current, Q is the charge, T is for time. Okay, and for currents, since you're dealing with electrons, you have to also use the ratio. For every 1 mole of electrons, there's 96,485 coulombs of charge, and that's Faraday's constant, if you remember from the previous lectures. Okay, you also remember voltage. Voltage is the amount of energy per 1 coulomb of charge. Okay, so you have to memorize these three, and I'll help you get a mnemonic device for this. So the way I remember volts is Viva Jesus Christ, Viva JC. Okay, that's how I remember that one. This one, by the way, if you don't like these mnemonics, please make up your own. Okay, so this one is WJS. What would Jesus say? Or you can do something else. ACS would be American Chemical Society. Okay, so take a moment to memorize those, please. Okay, so now we're going to go ahead and talk about watts. Watts is a unit of electrical power. It's the rate of energy expenditure. Okay, so a watt is what would Jesus say, right? It's the amount of energy used for every second. Now, if you multiply the watt and the second, you put this on this side, you're going to get joules. So joules is the amount of energy, right? That's the unit for energy. So 1 watt second is equal to 1 joule. So a watt second is also a unit of energy. It's equivalent to 1 joule. Okay, so if I ask you, what is how much power does your TV need? So your television needs about 0.250 kilowatt hour. So you're wondering, what the heck is a kilowatt hour? Well, you see the watt there and the watt there, and you see the seconds and the hours, right? So it's just, these prefixes change the value a little bit, but it's a unit of joules of energy, okay? So what is 1 kilowatt hour? Well, 1 kilowatt hour. So I know that 1 kilowatt is 1,000 watts, right? I also know that 1 hour has 3,600 seconds in it. So if I multiply that, it really just means 3,600,000. The kilowatt cancels with this, the hour cancels with this, and this is now watt second. And you know that watt second is just equal to, what is a watt second equal to? It's equal to joules. So this is the same as 3,600, I'm sorry, 3,600,000 joules, and that's a unit of energy. You can also change this to kilojoules, of course. It'll be 3,600 kilojoules. So now that you understand that, let's go ahead and do some practice. So calculate the number of kilowatt hours of electricity. How much, pretty much that's going to be in joules, right? How much energy do you need of electricity to produce 1.3 kilograms? So that is, I'll just say that's 1,000, right? Kilograms of aluminum. Okay, let me think about aluminum. To make aluminum, it says I have to use electrolysis and I have to start with aluminum plus 3. So aluminum plus 3 is going to need 3 electrons to make it become aluminum solid, right? Okay. And the voltage I'm applying is 4.50 volts. So let me just summarize everything I know so far. 4.50 volts is the same as 4.50, oh shoot, is the same as 4.50 Viva JC per 1 coulomb. So that is going to be a conversion factor, okay? I also know, since I'm dealing with electrons, that 1 mole of aluminum is going to give me 1 mole of aluminum is going to need 3 moles of electrons, because it's aluminum plus 3, right? To become aluminum plus 3, right? That's also conversion. I also know that 96,485 coulombs is what I need if I had 1 mole of electrons. Okay, so I know all those conversions. So I'm just going to start with the singleton right here, which is 1,000 kilograms. And they're asking me how much kilowatt hour I need. So let me just do that. So let's start. I have, starting with this number, which is 1 times 10 to the third is 1,000 kilograms. Okay, 1,000 kilograms of aluminum. I'm going to go ahead and change that to grams. 1 kg is 1,000 grams of aluminum. I'm going to go ahead and change that to, I think I should change it to moles so I can use this, right? 26.98 grams of aluminum is 1 mole of aluminum, right? 1 mole of aluminum is going to need 3 moles of electrons because it needs to come from +3 to 0, right? 3 moles of electrons. Now I'm just going to use these conversions. I used this already. I can use this one, right? 1 mole of electrons is going to give you 96,485 coulombs of charge. Okay, so that's done. I use this one. Now I can use this one because the coulombs will cancel. 1 coulomb is 4.50 joules. Okay, so the coulombs is gone. So let me just cancel these things really quickly. Kilogram, kilogram, grams, grams, mole of aluminum, mole electron, coulomb, coulomb. Now I just figure out how much energy I got in joules. And do you remember that kilowatt hour is an energy unit in joules? So from here, I'm going to go to the following. So joules is equal to watts. So let me just go ahead and another conversion would be, what would Jesus say? Watt is J over S, and so isn't J equal to W times S, right? So 1J is 1W times S. So I'm really close to kilowatt hour. So now I just have to convert these, right? So I need to convert watts to kilowatts. So 1,000 watts is 1 kilowatt, right? And then now I have to convert seconds to hours. 3,600 seconds is 1 hour. Okay, so when I'm doing the unit cancellation, I have joules is gone, watts is gone, seconds is gone, and I'm left with kilowatt hour, which is the amount of energy, right? So go ahead and do that calculation. You should get 1.34 e to the 4th kilowatt hour of energy to make aluminum from aluminum plus 3. So in your textbook, there is a sample a practice exercise in 20.15. Do that on your own and see if you can get the right answer before you watch the next video.